Hi and welcome back. Bob Wilkins here. In this part 2 we will set up an auto reversing system on O-scale 3-rail track. There are 3 important requirements that we discussed in part 1. Firstly, the system only works in DC mode with a variable DC controller. Secondly, the trolley or locomotive must travel back and forth without any switch or direction control electronics. And finally, the motor should be of the can type, drawing less than 2 amps of current. In O-scale with 3 rails, the middle rail is by Lionel standard set up as the positive rail when the Lionel controller is set in the forward direction and the locomotive moves from right to left. This is the opposite to other gauges such as in HO or N-scale. So when a standard HO controller is used with the locomotive facing to the left and the controller is set to the forward position, the locomotive will move backwards, left to right, and will stop at the end. The reason for this difference is that in O-scale the polarity of the motor is opposite to that of other gauges. This could be changed by desoldering the wire connections at the motor terminals and resoldering to the opposite connections. The simpler alternative is to accept the situation so that if you do use a standard HO controller, let the forward movement of the locomotive be right to left when the controller is set in the reverse direction. If you change the direction of the controller to the forward, the locomotive will move backwards to the right and stops after crossing the rail gap. So for auto reversing systems, the controller is merely used to set the speed of the locomotive. The direction setting will be based on the diode settings. As discussed in part 1, the diodes for the larger scale locomotives are rated for 2 amps. They are soldered across an insulated rail joint or a gap cut in the middle rail. Remember that the diode only allows current to flow in one direction, from anode to cathode. It is this principle that is at the heart of the stopping of the locomotive at the end of the track. The grey band on the diode indicates the direction of allowed current flow from the unbanded side toward the grey band. With the auto reverse setup, both diodes must face in the same direction. When current direction is reversed, the locomotive will move in the opposite direction. The changing of direction current is controlled by the timing set on the auto reversing relay board. In O-scale, there are 2 options for diode setup. Option 1 is to set the diodes up as they are for other gauges, with the forward movement being in Lionel's mode, right to left, and with the positive wire from the controller set on the middle rail. Using this setup with a common standard HO controller, the reverse on the controller moves the locomotive forward from right to left, and the forward setting on the controller moves it backwards. In each case, the locomotive stops when it crosses the diode gap. With this setup, however, if you face the locomotive to the right and turn the controller on, the locomotive will run off the track. If you use this setup, 1, it is a good idea to label the forward and reverse directions on the controller. The diode and the gaps are positioned on the middle rail. As stated, I prefer setup 1 as it maintains Lionel's requirement for middle rail positive and forward movement right to left. The standard controller will, however, have to have the directions opposite. If you want the locomotive to move forward from left to right, you need to use setup 2. With the diode soldered in the opposite direction. You could use setup 1 and just turn the entire track around, as the rail links will prevent you from just swapping the end track. With the newer Lionel Fast Track, it is possible to just reverse the stop tracks which contain the diode, which we will discuss. Now let's look at the train controller. You can select any type of HO controller that has a variable direct voltage and current output of 12 to 14 volts. Identify the positive terminal by turning the controller dial or switch to its forward position and test the output terminals using the voltmeter. When the voltage reads positive, you have identified the positive terminal. Mark the terminal with the screw with a marker, preferably in red. Most of the old train controllers also have a fixed AC output. Do not use this output to operate or power the auto reverse system. You can use it in conjunction with an AC to DC 9-volt converter board to power the auto reverse board itself, instead of using a battery. On small displays and short layouts, a train speed controller such as that described in my previous YouTube video and in Project 25 at our website can also be used. It gives fine control over the speed of a trolley or locomotive being used. Preparing the insulated gap is the next step. The insulated gap at both ends of the layout across which the diodes are soldered are made as stated on the middle track. You can place them across an insulated rail joiner or cut a gap in a single piece of rail. This latter method eliminates the need for two pieces of track to make one diode connection. When using two pieces of track, remove the middle rail joiner and insert either an insulated rail joiner or a piece of insulated material into the joiner holes to keep the track aligned. I use a Q-tip with the cotton ends cut off and cut the rod the size of the rail joiner removed. Connect the two pieces of track and solder the diode across the insulated joint. The other method is to take two half-straight tracks, 5 inches in size, and cut a rail gap in the middle rail away from the track supports. Use a Dremel type rotary drill with a diamond cutting blade and wear safety glasses to protect the eyes. A hacksaw might also be considered. Maintain the alignment of the track by gluing some plastic or wood to the underside of the track with CA superglue. Solder the diodes across the track facing in the same direction, depending on whether you use setup 1 or setup 2, that is how you want the forward movement of the locomotive or trolley being used. Use a voltmeter or LED with a 1K resistor attached and a 9-volt battery to test the circuit to confirm that no current crosses the diode when the current is on the same side as the grey band, but does allow current to flow when set opposite. The stopping rails will be set at each end of the layout, set with the grey bands pointing in the same direction, depending on whether you are using setup 1 or 2. For users of O-scale fast track, we recommend cutting the gap in the middle of two short rails, Lionel's 1 3/8 inch track sections, labeled item number 12073 or 12074. The diodes are soldered across the gap that is cut with the Dremel drill and diamond disc cutter. The nice thing about this track is that reversing the setup, as with setup 1 or 2, only requires swapping these tracks. Now you can set up your intended layout of a point-to-point design. It can be straight, curved, switched, or even crossover in design, as long as it is one way out and one way back, a point-to-point layout. As an example here, I am using a straight point-to-point layout using diode setup number 1. Now connect the wires from the controller to the track with the positive wire going to the middle rail using the Lionel lock-on or by direct connection. Place a locomotive on the track facing to the left. Turn the dial with the controller forward. The locomotive should move left to right and stop once it crosses the gap. Now turn the dial to reverse and the locomotive will move right to left in its forward state. Both should stop at the rail gap. If you place the locomotive in the opposite forward position and operate the controller, the locomotive will run off the end of the track in both directions. If you want the locomotive to operate forward from left to right, reverse the layout, or if using fast track, just reverse the stop tracks, or use setup number 2 for the diodes. Once you have the setup operating so that the back and forward movement of the locomotive stops at the rail gap, you are ready to calculate the on and off times for programming the auto-reversing board. Measure the time it takes for the locomotive to travel forward and add to it the time you wish it to have it stop. This will be the off time for the board. Now reverse the locomotive to the other end and let it stop. Measure that time for travel plus the stop time, which will now become the on time for the programming of the board. Set up the auto-reversing relay board for programming. It does not need to be connected to the track. Connect the battery via the battery holder or plug with a switch to the single blue terminal, making sure that the red positive wire goes to the port labeled VIN, voltage in, and the black negative wire to the port labeled GND or ground. Be sure to use an alkaline or rechargeable battery, not a heavy-duty battery. A 12 or 9 volt DC voltage transformer can also be used to power the board. Okay, we're going to program the relay board for about 10 seconds in both the forward and reverse motion. We have our alkaline or rechargeable battery here, our switch to turn the power on and off, the cables going in to power the board as shown here. This is the key that we will use to program. The D1 LED is here, the D2 LED is down here. Now to turn it on, we turn the switch and you'll notice that the D1 blinks. We press the key and hold it down until D1 comes on. We then press it twice, D1 will go off. Press it again and it will start to blink. It's blinking now and setting the off time, the time for the train to travel forward and then stop. We'll make this about 10 seconds. 3, 2, 1. Press it again to stop it, and now that time is programmed. Press it again and hold it down and D2 will come on. We're ready to program the on time. Press it twice, D1 goes off, D2 stays lit. Press it again, D1 starts to blink again, and it's now programming the on time that the relay has reversed the current. Again, the train is traveling backwards and will stop, and we will stop that at about 10 seconds. Turn it off and then turn it back on again. D1 will blink, and we now should be set for the on time, the off time first, which is about 10 seconds. Then D2 will come on as the train has travelled back. Now D2 is on. It's now travelling in the reverse mode. It will stop, wait, and then go back again when D2 goes off. So it's now cycling at the program times that you have set for it. It's now in the off time. When D2 is on, it's the on time. So I'm going to turn it off now, and that's how to program the relay board. Now that the relay board has been programmed, it can be installed on the layout. First, connect the wire from the controller's positive terminal to the P+ port on the relay board, and the negative terminal wire to the P- port. The P stands for power in. Next, connect the wires from the M+ and M- motor ports of the auto-reversing board to the track terminals of the Lionel lock-on. The M+ wire will go to the terminal 1 of the lock-on, that is the middle rail position, and the M- to terminal 2. Now turn on the auto-reversing switch so that the board can begin to cycle, with D2 going on and off. Place a locomotive on the track in the center facing in its forward travel direction, and turn the dial or switch either way to set the speed. The auto-reversing timing will take over, so that when the locomotive reaches its end, it will stop after a short period and return to the other end according to the programming. If you wish to change the times, simply turn the controller and the auto-reverse board off. Then turn the auto-reverse board back on and go through the programming steps as before. There is no need to disconnect the board from the track. Should you wish to try this 3-rail O-scale project for your layout, you will find the items needed at our website under Project 26. These items include the large-scale auto-reversing kit. This kit can be used for O, S, and G scales. The kit includes the auto-reversing relay board, a 9-volt battery pack with switch, 2 diodes rated for 2 amps, and an adapter plug for a 9 to 12 volt DC transformer that you can use to power the auto-reversing board. Instructions for installation are also included. In addition, a variable speed controller, which can be used to power the motor of the locomotive or trolley, along with a 12 volt DC transformer rated for 2 amps, is available. There are 2 options for powering the auto-reversing board, including a 9 volt DC wall transformer and an AC to 9 volt DC converter board for the AC output of a standard HO controller that you may be using. Meanwhile, here are a few examples of our auto-reversing system. Firstly, this industrial rail trolley, which has been modified by removing the electronics, removing the bumpers, connecting the CAN motor to the track pickup, along with new bidirectional red and white lighting, and cabin lighting is shown. And a steam locomotive with a sloped tender. No modification was required here with this locomotive. Lionel introduced CAN motors in 1979, so many locomotives with numbers in the 80s series can have CAN motors, but check before buying. The details discussed here can be found in a PDF file at our website, modeltrainsounds.com, under Project 26. Thanks again for watching. We are still working hard on new upcoming projects for our model train hobby, so be subscribed. Bye for now.